When it comes to the design process, whether you've just started or you've been designing for years, the ultimate goal is always to design a product that meets a defined set of specified goals. This includes the functional requirements, such as resisting loads and forces, physical constraints, the materials used, the various manufacturing methods, and finally the performance criteria. All these aspects are core ingredients for great design. Traditionally, the design normally starts in your mind, and then it's your job to build and document that solution within your design application. Now, what if you need to explore multiple solutions of a design problem, but you don't even know what the design should look like? This happens all the time. You've been told what the design should do, but you don't know where to start. This is when you turn to Fusion's generative design. It's an alternative approach where you provide all your design objectives first, and the generative design cloud-based platform procedurally synthesizes a large number of options that meet your specific design criteria. So generative design creates a vast number of potential designs, and these designs are returned to you with all the performance data to help you make a clear choice. At any time, you can adjust your specified goals, and generative design will reanalyze the data and deliver a fresh set of solutions based on the updated design criteria. You're also able to tweak your design further in Fusion 360, and you can even export the selected solutions to other design and analysis tools. One key point is that these designs have been created with manufacturability in mind. Now let's compare the generative design workflow to what you already know. It doesn't matter whether you're designing a bracket, a chair, or even a part for a vehicle or building. They all have the same starting point: a set of design goals. So traditionally, you would start thinking about the form factor, the goals, and the constraints in order to start creating your design within your application. Normally, you would visualize the form factor of your design to get started, but the functional and manufacturing requirements for your design may only come later after other stakeholders get involved. So your design will probably need to be iterated multiple times to meet its goals. Now, iterating is a good thing. In fact, it could lead onto inspiration for alternative designs. But there is no guarantee that the new designs can actually be manufactured. So it's a great start, but there is so much more work to be done. Now, we all work to deadlines, and being human, we normally tend to focus on one design or possibly a few. Time is our biggest constraint, and trying to innovate and create multiple solutions to a design problem is sometimes severely limiting. But all of us get there in the end, but we don't know if we've made the right trade-offs. So taking a wider perspective of traditional design, you're actively doing most of the work within the toolset of your application and limiting your ability to explore alternatives. Now, generative design takes a different approach to the whole design process. Instead of thinking about the design and then creating it within your application's toolset, you simply tell the specific goals to the generative design platform. For starters, what do you want the design to do? How strong must it be? What materials could be used? And which manufacturing methods are available to make this design? With the use of AI and cloud computing, generative design will start working and produce a range of solutions based on your set of goals. Now, unlike traditional design, you don't even need a starting shape for the design. All you need to specify are the portions of the solution that must be present in the final form. Generative design first considers the functional and manufacturing goals and uses this information to synthesize the physical form. In doing so, it can produce a much wider range of alternative designs in order to meet your needs. This takes into consideration your constraints as well as materials. You can then take the initial designs and continue to refine them further. With any new goals or constraints, generative design can continue to refine and produce even more designs based on your updated criteria. So you can interactively explore multiple design potentials instead of just one or two designs. All of this is based on many clever algorithms in order to solve the design problem. Generative design can also help you discover unexpected and even better performing types of design potentials. And finally, what's great about generative design is that all the designs are ready for downstream usage in your workflow. So either use your selected designs as editable geometry in Fusion, or export them to other design and analysis solutions. So in conclusion, generative design is a great step forward in human-machine interaction. Generative design is not here to replace engineers, but to help you explore the design space effectively. So you can generate many solutions to your design problems in order to augment the engineering process. And this will encourage better interaction as well as more concise decision making. You define, generate, and explore with generative design. Now let's start taking your next steps into working with generative design.